Hello everyone. So today we'll study a very important algorithm, or we can say a very important topic, that is Hakimi algorithm. So prior to this, we have to know some basic definitions. The first definition that we'll learn today is degree sequence. We know what is the degree of any vertices. Now we'll study what is degree sequence. Okay, so what do you mean by degree sequence? So degree sequence means sequence of degree in non-increasing order. Okay, I'll write it for you. Sequence of degree in increasing order. Okay, or you can say in descending order. Okay, now when we take some example, it will be very clear to you. Let me take one simple graph. Something like that. Okay, so I can write the degrees of every vertices. So it has 1 2 3, and we know that the self loop count twice. So 1 2 3 4 5, it is having a degree of 5. This is having 1 2 3 4. For this is having degree 1. This is having 1 2 1 2 3 4. So this is having degree 4, and this is having degree 1 2. Okay, so what will be the degree sequence of it? What is the degree sequence of this graph? We can write the maximum degree is 5, then we have 2 4s, then we have 1 2 and 1 1. So this is the degree sequence of this graph. Okay, clear? I think this is clear. This is example 1. Now we'll see another example. Okay, next let me take another graph. Okay, this is the graph. Okay, so I can write the degree of the each vertices. So it has degree 2, it has degree 1 2 3, it has degree 1 2 3 1 2 3 4 5. This is having a degree 2. So what is the degree sequence? What is the degree sequence? So the maximum is 5, then we have 3, then 2, then 2. So this is the degree sequence of this graph. Okay, clear? Next the second definition that we have to know, that is graphic. Okay, what do you mean by graphic? So graphic is a degree sequence. Okay, a degree sequence is called graphic if there exists a simple graph corresponding to it. So I'll say it again. So a degree sequence which may form a simple graph, that degree sequence is called graphic. So whenever I write it, then this will be clear. Okay, sorry. A degree sequence which can form simple graph can called as graphic. Okay, so I think this is clear. So whenever a degree sequence can form a simple graph is called graphic. Then we'll go to the algorithm, that is Havel-Hakimi algorithm. Okay, so why we use this algorithm? Okay, so we will use this algorithm to find whether a degree sequence is graphic or not. It means if we are given a degree sequence, we can predict or we can detect that whether it can produce a simple graph or not. Okay, so there are some steps regarding these algorithms. I will write it one by one. Okay, it has 3 steps. So step number 1, first of all, step number 1, step number 1. Okay, arrange the degree sequence in ascending order. Ascending order or non-increasing order. Okay, now step number 2. This is the first step, then we have step number 2. Okay, so the step number 2 is delete the first vertices. So delete the first vertex and say k, and then subtract subtract 1 from next k nodes. Okay, so when I take an example, this will be clear. Okay, now step 3, getting? Now step 3 is saying that repeat 1 2 step 1 step 2 until stop condition. Okay, well, so what is stop condition? I'll write. So stop conditions. Okay, there are mainly 3 stop conditions. First one is all degrees are 0, then we can say that degree sequence is graphic. Degree sequence is graphic. Okay, great. Next, the second stop condition is any negative entry. Okay, any negative entry, then we can write it like this, that degree sequence is not graphic. Okay, great. Now the third condition is not enough entry. Then also we can predict that that degree sequence is not graphic. Okay, so there are mainly three step and 3 stop conditions. So first step is arrange the degree sequence in non-increasing order, then delete the first node and subtract 1 from the next k nodes and repeat 1 2 until the stop conditions. So what are the stop conditions? First, all degrees are 0, then we can say that degree sequence is graphic. Any negative entry is present in the any negative entry present in the degree sequence, then we can say that degree sequence is not graphic. And if not enough entry is present in the graph, then also we can say that the degree sequence is degree sequences is not graphic. When I will take example, I'll assure you that it will be very much clear. Okay, now example 1. Okay, I am taking one degree sequence. Okay, the degree sequences is like 8 7 7 6 4 2 1 1. Okay, so according to the algorithm, arrange the degree sequence in the ascending order or in the non-increasing order. So it is already in the non-increasing order. Okay, great. Now, so the step 2 is saying delete the first vertex. Okay, so I am deleting the first vertex. Great. Now subtract 1 from the next k nodes. Okay, so I am deleting the first node, and that is 8. So according to the algorithm, I have to subtract 1 from the next 8 nodes. Okay, now count 1 2 3 4 5 6 7. So it doesn't have 8 entries, it have only 7 entries. So according to the stop condition 3, not enough entries, so we can say that this is not a graphic. Okay, we can conclude that this is not a graphic. Are you able to understand? I am repeating once again. So at first deleting the first node, then subtract 1 from the next k nodes, but it doesn't have the 8 entries because the first node is 8. So as it doesn't have 8 entries, so we can, according to the stop condition 3, that not enough entries, so we can conclude that it is not a graphic. Great. Now example 2, I am taking another degree sequence, that is 6 6 6 6 3 3 2 2. Great. So according to the algorithm, at first I have to delete the first node, and this is 6, so I have to select 6 entries, the next 6 entries, that is 1 2 3 4 5 6. So I am selecting 6, and we have to subtract 1 from the 6 entries. After deleting that, the degree sequences will like, so I have to subtract 1, that will 5, subtract 1, 5 5 2 2 1 2. Okay, so I have done the first 2 steps, then repeat 1 2 until stop condition. As you can see that we haven't come to the stop conditions here, so we can go to the step 1, that is arrange the degree sequence in the non-increasing order. Okay, so this is not in the non-increasing order, so I have to arrange it. Okay, so this will be like 5 5 5 2 2 2 1. Great. Next, the second step, the delete the first vertex. I am deleting the first vertex. Great. Then select the 5 entries, 1 2 3 4 1 2 3 4 5 entries, and I have to subtract 1. Okay, so after subtracting 1, this will be 4 4 1 1 1 1. So now this also is not a stop condition, so I have to repeat once again. Then the first step is arranged in a non-increasing order, so this is already in the non-increasing order. Then delete the first vertices. Great. Delete the first vertices. Great. Then I have to select the four vertices and subtract 1. Okay, so this will be like 3 0 0 0 1. Next, so this is also not a stop condition, so we have to go for the another iterations, that is arranged in a non-increasing order. So I'll arranging it in non-increasing order. Okay, now the second step is the delete the first vertices. Okay, I'm deleting the first vertices, then select the remaining the next 3 nodes, and then subtract 1. So this is 0, this is -1, this is -1 0. So what is our what we'll have after this operation, that is 1 -1 0. Sorry, 0 -1 -1 0. So according to the stop condition 3, that if it contain any negative entries, then it is not a graphic. So it contain 2 negative entries, so we can say it like this is not a graphic. Great. Next, I think you are understanding this. Now example 3. 7 6 6 4 4 3 2 2. Okay, now according to the algorithm, now I have to delete the first vertices and select 7 entries, 1 2 3 4 5 6 7. So and subtract 1 from the remaining 1. Okay, next, this is not a stop condition, so we have to go for another iterations. So delete the first vertices and select the next 5 vertices and delete 1, so subtract 1 from them. So this is 4 2 2 1 0 1. Then this is not in the ascending or not in the non-increasing order, so I have to arrange it in a non-increasing order, that is 4 2 2 1 1 0. Great. Then again we have to delete the first vertices, and from the remaining 4 we have to subtract 1, that is 1 1 0 0 0. So this is already in the non-increasing order, so we can select the first vertices, and as it is 1, we have to select 1 and subtract 1 from them, so that we have, that is 4 zeros. And according to the stop condition 1, if all the degrees are zeros, that we we can see the result is here. So we can conclude that sequence is graphic. Okay, I think everything is clear to you. So you can I'll explain what we have discussed till now, that what is degree sequence, then what is graphic, then we have discussed what is Havel Hakimi algorithm. We can go to step by step, and we have given 3 examples. And one small thing I will give, that is not very much important. The time complexity of this algorithm is theta of n square log n. When I will do the video on algorithm, then I will discuss how this is n square log n. Those who have studied already, I'll give, that is, in the first step we are arranging, so we have to apply sorting algorithm, that is n log n. And in the worst case, we can go for the n vertices, we have to subtract 1, so that is n times. So the total time complexity is n into n log n, that is n square log n. So I think everything is clear. This is for today. Thank you very much.